Hey guys, and welcome to Functional Print Friday. So 3 or 4 years ago, I fixed this pressure washer with a 3D print. This used to be my pressure washer. I fixed it and then gave it to a friend of mine because I had gotten a newer, larger one. I think he used it like twice and it failed again. And it's sat since, so even if we get this fixed, we might have a will it start because I think this has 2-year-old gas in it now. So let me get this up on something that we can see it better and I'll show you what I'm talking about. All right, I put a pan underneath here so that if we lose more oil, we can hopefully get it back in. I think it's been a while since I worked on this, but I think there's a specific amount of milliliters of mineral oil that's supposed to go in this guy. I think we might actually have to drain it fully, measure it, and add some to it to get it back to where it's supposed to be. So this is, I believe, ABS, and this is one of the original plugs. The other plug, I think, cracked, broke apart, and this guy drained out. And I made this one. Yeah, this is like super loose in here. And it's got an O-ring as well. Oh yeah, yeah, this warped. Now, I think it just warped due to heat. I don't think the mineral oil affected it. Can you guys see this? So it's not supposed to be that curved shape. I think what happened here is it's like a twist lock plug that retains it, and I think this guy just got too hot, warped, and then allowed this plug to come loose because this O-ring goes up here on this shoulder and seals that against the outer face. So that's our sealing surface there, if you can see inside of there. Let me get you guys out of the tripod. I'll give you a good look at what we're working with. Okay, so you see there's a larger bore that the plug goes into. It looks like just squared off section inside that it twist locks onto, and the shoulder inside here is where that O-ring goes against. So the O-ring does the sealing work. We just need something that is going to seal against, that's going to twist lock and stay in there and not warp or stretch at all, because we need that tension to keep the pressure against this shoulder here for that O-ring to seal. So I'm thinking maybe TPU. At the time that I made this, I had only an ANET A8 and was only printing in PLA. So PLA was the answer for everything. I think TPU is going to have a higher temperature tolerance and should also be plenty strong enough. Maybe if we print it a little bit oversized, because it's going to stretch a bit. As we turn it in and twist lock it, the material is going to stretch a little bit. But if we do it slightly undersized on the length so that it's tight, it might work. Let's try doing this in TPU and see what we come up with. And here is my original design for this. And again, I designed this a couple years ago, and I just copied the design of the one good plug that I had. I think the one that broke failed right here. It failed at this stress point between this face and this part of the shank. There's not a whole lot to this design. I probably got a little bit crazier with it than I needed to, like putting the recess in here for turning it with your thumb and forefinger. The only surfaces that really are super important here is we need a nice flat face here because this is what presses against or preloads that rubber O-ring. We need this diameter here to be a fairly close fit inside the first part of that bore. And then this is like a twist lock plug. So as you twist it, there's actually, if you look at the height difference here, it's obvious. This ramps up. So we push this in and then turn it. And our tightness comes from two things. It comes from the fact that we are, forcing the plug in by sort of driving up this ramp as we turn it. But then there's also this sort of keyed section here where it kind of goes over a hump and then sits against the flat face and can't walk itself back off unless you actually grab the end of it and twist it. So the design itself worked fine. It wasn't until this upper portion here, this guy warped. You saw in the PLA one, it just sort of bent into a C shape, allowing this guy to come out on its own. I'm hoping that the temperature that TPU is going to tolerate is a lot higher, although I don't know that for sure. Technically, the glass transition temperature of TPU is below freezing because it's flexible at room temperature, but I don't know exactly what temperature it will deform or sort of soften up and stay in that new shape. I think it's a lot higher than PLA and PETG, but we're going to find out. So what I think we need to do is just to reduce the height of this section here a little bit, because TPU is going to give a bit. You see we have this ramp here again that tightens this guy in. The PLA doesn't give at all. There's no flex to it, or at least there's no flex to it with the amount of force that this would apply. The TPU is probably going to give a little bit. So what I'm thinking we'll do is we'll just bring this section down. Make sure we're on the right axis. We'll bring it down like 0.5 millimeter. And it probably doesn't look like a big difference here. I'll hit undo. You can see that's how much we're bringing it down. And what I'm thinking that's going to do is that's going to just place a little extra preload against this to accommodate for that give in the TPU. So, all right, let's print one of these and see how it works. All right, looks like it came out good. I gotta pull the support off. It doesn't seem too flexible. I printed it at 50% infill. Obviously I want it to be stiff in this application. I'm hoping to just sort of exploit the other properties of TPU, like its thermal stability at a higher temperature. And I mean, some flexibility is good. I mean, it's gonna kind of spring a little bit, I think, to stay tight in there against that O-ring. So let me get the supports cleaned off and bring you back. All right, I think I got that cleaned up pretty good. I really wanted to make sure I got all the small pieces off of at least this end, because anything that would come off of this end could potentially end up inside that the pressure pump. This side's just cosmetic. I'm not really worried about that. It's just got to be able to be gripped to turn it in. So it feels pretty stiff. I think unless it heats up enough to flex, I think it's going to be okay. And if I bring in the original one, you can see how much that warped before it came loose. There's no way there's that much flex in this TPU at the force that this guy holds in there. Now, that's not to say that this won't also heat up and sort of reach its plastic state and bend, but I don't think so. I think, see, PLA will warp at a much lower temperature. This does not have to be anywhere near the temperature that you'd get to extrude it for a print for it to do this. It softens. That's why you don't want to use PLA on, like, say, a print in your car that's going to sit out in the hot sun. No, you don't get anywhere near the temperature you do in the extruder, but it gets hot enough to sort of warp like that. I don't think we're going to have that with TPU. So let's see how this fits. I was turning it the wrong way at first there. It's actually, I was about to say, boy, it's really tight, but I was just going the wrong way. And also that O-ring needs to be pushed through so that it's seated inside that ridge. Honestly, that feels good. As long as it doesn't flex very much, we are compressing the O-ring a bit, because it's like that's about where it wants to be, and then when I twist, it's sucking it in maybe another 5 thousandths. So now the question is, how much oil did he lose from this this gearbox / pump? All right, so I checked the manual and it calls for 4 ounces of mineral oil. So Yeah, I think, and it doesn't say anything about the fill level, so I think we're going to have to actually drain this and measure it and refill it. Ew. Thinking we might just put all new oil in there. That looks terrible. So that actually looks like, you guys probably can't see down into the pan there very well. That looks like motor oil. Maybe he changed the oil in this or tried to put new oil in to use it. I'm not sure, but it shouldn't be that dark. So I'm gonna get all this out of here and we're just gonna put 4 ounces of new mineral oil in. Okay, so I've got a couple of these huge syringe looking things. There's my hand for scale for stuff like this. 4 ounces is just under 120 milliliters, and this only has a milliliter scale on it. So I think what we can do is just draw somewhere between the 115 and the 120 of mineral oil up into this guy and hopefully squirt it into the top hole, and we should be good. Okay, that's like 135 in there. Bring it down to just under the 120. And maybe I can tip this guy up a little bit. Trying to see where the level is in there. Yeah, it's, you know what? I think it's basically, yeah, it's just over, the fill level appears to be just over the, where it would dribble out. And there might have been a little bit left in there, so if we end up repeating this, I think we know we just fill about to the level of that second pole. I want to get most of this wiped off because if we're leaking, I want to see it. There's also oil like all over this guy. What I think happened was, I thought maybe the crankcase was leaking here. I don't think it is. There is a small hole up here. Yeah, there's a gap up here. I think what happened is, I think it was just blowing oil like crazy out of that hole inside there when that plug came out, and it just went all over the place. This is just a degreaser. All right, let's get this down off of this platform. Let's dump this old gas out, put some fresh gas in, and see if she's going to fire up. It's actually dry in there. I don't know if it evaporated out or if he ran it out of gas, or maybe he did remember to drain it. So we might be okay here. I'm going to go get some fresh gas and let's try it. Oh, you know what? We should check the engine oil too, now that I think about it. Yeah, it's right at the full. All right, so the first thing I have done is disconnected the high pressure line from the gun. What this is going to do is allow the pressure washer to just pump without any restriction through this line, so that we're not putting it under load. I want to just bring it up to temperature, make sure that it's going to hold, you know, under just light use before we test it under real use. And I did notice on this end, this is the end that goes into the pressure washer, the high pressure output. The O-ring here is split. I think I've got some O-ring kits. Let's see if we can find the right one. So you might be wondering why I'm going through all this if I'm not even sure it's going to run yet. And that is because I mentioned before, this has a gas engine on the top and the pressure washer part on the bottom. The gas engine is it's air cooled, but the pressure washer pump is liquid cooled, and that liquid is the water going through the pump from your garden hose. And if you don't have liquid going through there, it's going to overheat. It's going to overheat pretty quick. That's why they say you don't want to leave the pressure washer running and then just walk away because, yeah, you have liquid in there, but that liquid is going to heat up and eventually even expand and make things even worse. But it's no longer going to be cooling the pump. That pump is dependent upon liquid constantly going through it. The cold water coming in from your garden hose, or even warm water, it's still way cooler than the water that's heating up in there. And then the heat is being taken away by the water coming out of the high pressure side. It's kind of between these two sizes. Actually might be in my other kit. One of these is metric and one of these is imperial, and I think this pump is Italian, company that makes the pump at least. So it's probably metric, I guess. Yeah, that one looks too fat too. It also might just be compressed. I think we're going to go with the one from the first kit. Yeah, this one's a little closer to my eye. These kits are nice to have. This is the type of thing, if you're working on a project that can stop you dead in your tracks and you're waiting for shipping or you got to run out an hour round trip to the store to get an O-ring. These kits are not expensive. I'll link these down in the description. The other thing I like to do for O-rings is put a little bit of this silicone lubricating grease on it. It's PTFE based. It's safe for rubber. Rubber gaskets, O-rings. It won't swell them like a normal grease. So not only does it kind of, I feel like, sort of prolong the life of the O-ring, but also makes it easier to get these fittings on and off. It just gives you a little bit of sliding surface. Give it a little throttle. What do you think? Is it fixed? Hasn't blown yet. It's been almost 10 minutes. I think we might have it. So it's actually stop is all the way to the right. That shuts the engine off. There's no stop button on this, so it was never going to start until I put the throttle up. So that ran over 10 minutes, I think, and it's not leaking at all. I'm tempted to pull that plug out and see if it warped at all. Let me bring it in closer. Hey, I don't see any warp at all on there. I think we might have gotten it. I can't set this down to bring that into focus. I don't know if you guys are able to see that or not. I can't see the camera screen, but it doesn't look warped at all to me. It looks totally flat, so I think we might have gotten it. Again, we don't have the gun on, so I think what I'm going to do is put the gun on, just hold the trigger open, and let it run maybe 5 minutes, and see what happens. Some smoking here. I think that is the mineral oil burning off that had sprayed up onto the top here from when it blew out before. Yeah, that's what it is. It's smoking off of the fins here. So let's pull the plug one more time. No, I don't see, hopefully it's focusing on that. I don't see any warping in that top part at all. Well, guys, I think I'm calling this one done. I let it run for over 10 minutes under medium load, without the gun on there, and it certainly got warm, but no signs of warping. And then I ran it for an additional 5 minutes with the gun on there, and twice during that test I stopped, or I released the trigger, causing extra heat to build up in there, and I counted to 10 each time, and no issues. And that's essentially what the manual says for this. That's an overheating case. You're not supposed to operate this or leave this operating with the trigger in the off position. You can for 5-10 seconds while you walk around to the other side of your vehicle or whatever else, but you shouldn't just let go of the trigger and walk in and make a cup of coffee. It's going to overheat. Bad things are going to happen. So I think, save for that case where this thing is intentionally overheated, I don't think this is going to fail. I think we basically got up to full operating temperature when I ran it under medium load, and then only gave it like a 1 minute break just while I shot that sort of in between scene, and then ran it under full heavy load for 5 minutes. Even allowing heat to build up in there. So I'm calling this fixed. Guys, thanks for hanging out in the shop with me today while we did this. I do a new video like this every single Friday, and I always give away all the designs for free. And that'll be the case for this as well. When I originally designed this and printed this one at PLA a couple years ago, it's probably 4 or 5 years ago at this point, I posted it on Thingiverse. You can probably still find it there, but I will post the design, or I should say I'll post the updated design for this on my site, fpfdesigns.com. And that is the one that I would use. I'm not going to go back and update the one on Thingiverse. I took just a 0.5 millimeter out of this part of the shaft again, just to tighten it up. And I think you would want to do that for TPU, because TPU is going to flex a little bit, whereas this PLA, at least before it warped, it's not going to flex like that. It's a very rigid material. So again, fpfdesigns.com, you can find the design there as well as all my other designs. And guys, if you enjoyed this video, please take a second, hit that like button. Really helps out the channel. And if you really liked it, hit the subscribe button. And guys, if you do, I'll see you next Friday.